Hello everyone. Today let's solve the Leetcode problem number 23. Merge K sorted list. So this is going to be the last problem in the linked list, right? So we'll be solving. So what the question says, you are given an array of K linked lists. So each linked list is sorted in ascending order. So merge all the linked list into the sorted linked list and return it. So let's come to the example 1. Here they have given input lists. So 1, 4, 5, 1, 3, 4 and 2, 6, right? The output that we have got is in the sorting, in the ascending order, nothing but 1, 1, 2, 3, 4, 4, 5, 6. So in the explanation what they have said, the linked lists are 1, 4, 5, 1, 3, 4 and 2, 6. These are different linked lists. Suppose if just for the understanding purpose, if we take this one as list 1, this we can consider as list 2 and this we can consider as list 3. Nothing but 1, 4, 5, 1, 3, 4 and 2, 6. Merging them into one sorted list, we will get 1, 1, 2, 3, 4, 4, 5, 6 in the ascending order, right? That's what the output is. So how can we achieve that? Let's see that what we can do, right? So just give me a second. So initially what we'll do, we will flatten this list basically. So we'll flatten this one. When we flatten the list, what we will get basically, so when we flatten the list, basically what we will get 1, 4, 5, everything we will get in the same array, right? 1, 4, 5. So next 1, 3, 4 and finally 2 and 6. So we have got, after flattening the list, we have got every single number in the single array. Then next step is we will sort this one in the descending order. So while we sort this one in the descending order, what we will get, just give me a second, it will be 6, 5, 4, 4, 3, 2 and 1. So let me do one thing. I'll just delete this one. So after flattening, we are sorting the list in the descending order. What we will get, 6, 5, 4, 4, 3, 2, 1, right? 3, 2 and finally 1. So just give me a second. Right. So next step what we'll do, we will add the list from this one, starting from the index 1. So first we will add this one to the list 6. Then we will add this one, we will add the next value, that is nothing but 5. Next we will add the next node, that is nothing but 4. Next we will be adding the next node, nothing but 4. This one, these 3 we have done. Next we will be adding 3. Next we will be adding the 2. Next we will be adding 1. So 1 is the last number, right, in the list. So it is the last node basically. So when the resulting this one will be, output will be 1, 2, 3, 1, 1 basically we have to get, right? So this has to be, somewhere I missed 1 and the final number is also 1, I think. So that I missed basically. It has to be 1, 1 and then this one 2. So it will be 1, 1, 2, 3, 4, 4, 5 and 6. That's what we got in the output, right? So let's see how can we write the code. Let's continue writing the code, right? So I'll just delete this one. Just come here. Let's start writing the code. Initially what I'll do, let's initialize the empty array to store all the node values. In my case, I'll just give let result equals empty array, nothing but this one. And the next step, what we'll do, we'll iterate over the each linked list in the input array. As I have said, we will iterate over the each linked list in the input array lists. So I'll just give, in my case, I'll just make use of for each. call this one L. Inside this one, while we have individual this one L, then what we'll do, we will traverse each linked list and collect all the nodes, right? For that one, I have just took the condition while of L. Then what we'll do, the first step, we'll add the current node's value to the result. How can we do that? I'll just make use of the push, right, to the result. How can we get the value? L dot val, right? What we have done here, we have added the current node's value to the result. Next, we'll move to the next node in the list, as I have showed in the example. How can we move to the next node in the list? I'll just make use of the next, L dot next, basically, in this case. So after doing this, let's sort the collected node values in the descending order. As I have showed you, we will just sort the collected node values in the descending order. For that one, I'll just give result dot sort A comma B. The sorting in the descending order, right? So this will be B minus A. Next step, what we'll do, if there are no values collected, so if there are no values at all, we will just return the null. So how can we do that? For that one, I'll just make use of the if condition. If result, the length of the result. So if it is less than 1, then we will return null. So this is one thing. Finally, what we'll do, first we will initialize the result linked list with the first value in the result. For that one, I'll just give n. So let result equals, new list node of initial one. Here in the example, after we have this one, got the list in the descending order, the first value was basically 6, right? So list node of 0, list node of within the result, it is in the array, right? 0, nothing but result of 0 is nothing but the first value. And the second, I'll just give, for now, it will be undefined. So let's iterate over the rest of the values in the result and finally display them. How can we do that? I'll just make use of the for loop. For let single value we have to attach, right? For that one, nothing but we are iterating over the rest of the values in the result. For that one, I'll just make use of the for loop. For let I equals 0, I less than length of the result, finally incrementing the I. So next what we'll do, we'll create a new node with the current value and link it to the current result list. I showed you how at the end we link the current values to the current result list, right? So basically here I'll just give result equals new list node of result of I result. So yeah, this is fine. Finally, we will return the head of the merged linked list. So at the end, what we'll get, we will get this one. This by taking this example I showed, we will get this one, right, as the output. So we have to, for that one, we have to return the result, right? So I'll just come here. Let me return the result. So let me format this code once and hit the submit, right? Getting wrong answer. So the output has to be this one, but we have got 6. One more 6 we haven't got. So one more extra 6 we have got here. So let's see what is wrong. So yeah, what mistake I have done here is I have already added the new list node result of 0, nothing but the first value, right? Here I have to add from the second value, not the first value. So initially it will be 6. We have already added here new list node of result of 0, as I've showed you in the example. After we have sorted in the descending order, the first value we got is 6. Again, we are iterating from the 0, nothing but we got the extra 6 here, right? So we have to start from the second value or the second node. So this has to be I equals 1, not I equals 0 basically. So let me format the code and let me hit the submit. This time we have to get the correct value, right? So yeah, here we are seeing the code is correct. So what would be the time complexity and the space complexity? So the time complexity would be big of n log n. Why? Here the sorting, the time consuming operation basically here is sorting the array result, nothing but this one. Array result is nothing but this one, right? So we are sorting the entire thing in the descending order. So the most time consuming operation is sorting the array result which has n elements. So the sorting time takes the big O of n log n time. So the time complexity would be big O of n log n. What is the space complexity? So we use extra space to store all the node values in the array result, and also for the new linked list we construct. So both of which that uses big O of n space complexity, nothing but big O of n space complexity. So here sorting is dominating, so we are getting, in simple words, big O of n log n time complexity, and the space complexity would be big O of n. So I'll just come here, let me give big O of n time complexity, and the space complexity would be big O of here this would be big O of n log n time complexity. The space complexity would be big O of n. So let me comment this one. So yeah, this is it. Thanks for watching, guys.